Jai Hind, welcome to the class of Fundamentals of Electronics Engineering. We are going to talk about communication engineering today. These are the contents. We'll be talking about fundamentals of electronics engineering, basics of signal representation and analysis, electromagnetic spectrum, elements of a communication system, need of modulation, and typical applications, fundamentals of amplitude modulation and demodulation techniques. Then further in this unit, we do have introduction to data communication goals and applications and general model of wireless communication, where we'll be covering topics like evolution of your mobile radio communication, GPRS, GSM, etc. First of all, what is electromagnetic spectrum? Electromagnetic waves can be thought as a stream of particles where each particle is moving with the speed of light. When it is moving with the speed of light but is a particle, then it is a bundle of energy, and this bundle of energy is called as photon. Now the radio waves which are actually your electromagnetic waves, they have the longest electronic wavelength in the spectrum. Why I am particularly talking about radio waves? Because this is of interest. Like, we are discussing the complete electromagnetic spectrum as a whole. Like, this is the electromagnetic spectrum, which expands from gamma rays to radio waves. Wavelength increasing in this direction and frequency increasing in the direction from radio waves to gamma rays, right? So right from the gamma rays, we have gamma rays, X-rays, ultraviolet rays, visible range, then we have infrared, microwave, then radio waves. So we can see the frequency is increasing from radio waves to gamma rays, whereas wavelength is increasing from gamma rays to radio waves. For communication engineering, or to perform communication between two nodes, radio waves are of interest. Hence, the radio waves are a particular kind of electromagnetic waves which have longest wavelength. Radio waves are generated and propagated by radio transmitters, and these are again received by radio receiver at another terminal, which converts this into mechanical waves played through radios and other devices. Due to their wide range, they are primarily used in communication systems like broadcasting, communication satellites, like computer networking systems, radar, and other kind of navigation. This is what we have discussed. Wavelength of radio waves falls in the range of meters, right? It's 10 to the power 3. Whereas frequency, we can see frequency increases from 10 to the power 4 Hertz to 10 to the power 20 Hertz. Gamma rays have maximum frequency lying in the range of 10 to the power 20 Hertz. Whereas this wavelength is shown in meters. Now again, I want to classify this, or again segregate the waves falling under radio waves. Then I can expand it into these starting few things which we have mentioned here. Radio waves can further be classified as extremely low frequency, ELF, voice frequency. Extremely low frequency lying in the range of 30 to 300 Hertz. Voice frequency in the range of 0.3 to 3 kilohertz. And corresponding wavelengths is written in meter here. And applications are also mentioned here, like extremely low frequency is used for power line communication. Voice frequency is used for face-to-face speech communication. We must know this is the frequency of, this is the frequency of speech signal, 0.3 to 3 kilohertz. This student should be familiar about it and should remember this, right? If we talk about speech signal, it has a frequency of 0.3 to 3 kilohertz. Now, if we talk about very low frequency, 3 to 30 kilohertz, it is used for submarine communication. Low frequency 30 to 300 kilohertz used for again marine communication, and medium frequency 0.3 to 3 megahertz used for AM broadcasting. High frequency is used for landline telephony, and the frequency is 3 to 30 megahertz. We can see 3 to 300, then hertz to kilohertz, kilohertz to megahertz, how it proceeds, right? Very high frequency 30 to 300 megahertz, ultra high frequency from 0.3 to 3 gigahertz, super high frequency 3 to 30 gigahertz, extremely high frequency 30 to 300 gigahertz. So these are all my radio frequencies used for various communication systems, like line communication to satellite to microwave to broadcasting, and AM broadcasting, FM broadcasting, all comes under this radio communication, right? Now, why are we studying communication engineering? And what is the need of a communication system in our environment, in our society? We know that a communication system is used to transmit messages, or my information piece is transmitted from one point to another. We can call the transmitting point as a source and the receiving point as a user. Now, what is actually communication? Communication is a process, right? So communication is a process of establishing connection or link between 2 points for exchange of information. Now there are two nodes. There are one transmitter, one receiver, or we can consider two people at distance. We have two people, like both are physically separated. Now they want to exchange some information. What is to be done first? There has to be a path established between the two persons. Then they start actually transmitting the information, right? So thus communication may be defined as a process of establishing connection or link between 2 points for the purpose of exchanging information. Now when we do have a communication system, the path is established, what is the next thing? We need some equipments that will help me do the purpose, solve the purpose. So what are those equipments? Those equipments are my communication equipments. So equipments are my electronic equipments used for communication purposes, and this complete system is called as communication system. Different communication equipments assembled together form communication system, right? If I talk about classification of communication system, a communication system can be classified on the basis of various parameters. Like, if I want to classify my communication system on the basis of what kind of equipment I am using, then it can be classified as simplex, duplex, and full duplex. What is a simplex kind of communication system? Here, my equipment is either capable of transmitting or receiving. We can take example of a simple facsimile machine, fax. It is capable of receiving only. It receives some input and what it gives, the printed form of output, right? Whereas it is not capable of transmitting. Then comes half duplex. A duplex system is capable of transmitting as well as receiving. Now when I classify it as half and full duplex, my half duplex system is capable of transmitting and receiving, but one at a time. It cannot perform both the things simultaneously. A walkie-talkie can be taken as example of a half duplex, where when we speak, we have to press a button, when we release that, and then we come into listening mode, reception mode, right? And full duplex, it is a kind of equipment that is capable of transmitting as well as receiving both simultaneously, like our mobile phone. We do talk and we do listen, both the things simultaneously, isn't it? So this is the classification on the basis of type of equipment. Now, if I want to classify my communication system on the basis of frequencies, like we have gone through AM spectrum. So if I want to classify it on the basis of the frequency that I am using for my communication, then it can be classified as baseband and passband. What is baseband? Communicating at low frequency. Baseband communication is low frequency communication. Like you're listening to me right now, but through some digital media. So this won't be called as baseband communication. If you would have been my live audience, where I would be using my vocal cords and I'm talking and you're listening by your ear, we are using no device in between, and we are using the frequency 20 to 20 kilohertz, which is my audio frequency, then that where I am doing nothing, I mean no processing, no changes in the signal. I'm just generating my voice signal and those are propagating through air, those are reaching your ear, you're listening to that. I'm not doing any processing, no digital techniques are applied on my signal, you're able to listen that. That kind of communication is called low frequency communication or baseband communication, right? But actually you're listening to me through some digital media, then this is not the baseband communication. Now this is my passband or bandpass communication, which is my high frequency communication. You cannot hear me using your ear only. You are using some digital receiver. Maybe you are using your laptop or your mobile phone to listen to this video lecture. Even I am not directly communicating, propagating my waves on the ear. I am using some equipment that is processing the signal, and this is somehow transmitting the frequency, and my actual frequency that gets shifted. It gets shifted from 20 to 20 kilohertz to some high frequency, and that complete procedure involved in this is called as modulation, multiplexing, and n number of things are involved, which you are going to study in detail in this unit. So when we are doing some processing on the signal and shifting our signal to high frequency and then we are communicating, that is called as passband or bandpass communication, right? So two categories of classification. Now if I classify my signal, communication system on the basis of message signal, like whether my message is analog or digital in nature, then I call my communication system as analog communication system or digital communication. I'll take an example. My audio signals are actually simple sine waves, right? Audio frequency, those are analog signals. So, but if you're communicating using analog signals, the basic form of signals, on the basis of type of message signal. Now, if you're using digital communication, that means maybe you're converting those analog signals into digital, now you're transmitting these bits. That kind of communication is called as digital communication, right? Now, I want to study my communication system as a whole. Now, what are the parts of my communication system? So, this comes under elements of a communication system. Communication means sending, receiving and processing of signal in between two or more devices as discussed. Now, collection of the elements, devices, which works together to establish a communication between the sender and the receiver is called a communication system. Right? Some examples of communication system include radio broadcasting, television broadcasting, radio telegraphy, mobile communication, computer communication. Two or more people communicating with each other by using sound signal is known as the any kind of signal, not only sound signal, is called as communication system. This is the block diagram of my communication system. We need to pay attention to this. These are the basic blocks of my communication system. Even if I eliminate certain blocks, what I'll be left with is first and most important thing, information source. For communication to be established and for exchange of the data, the required thing and the first and foremost thing is my data or is my information. I should be having a message to transmit, right? So this is my message, information source, right? Now, this message could be in any form, and an input transducer thus converts this form of energy into desirable form, which my transmitter is able to transmit via the channel. In the channel, noise gets added up. When it has traveled the long distance, it receives the receiver. Like if input transducer has converted my signal into electrical signal, up till here I have electrical signal only. Then output transducer will convert back my electrical signal into the actual format in which my message was. That could be my picture, my text, video, right, some audio. Then it reaches the desired destination, right? Hope we get it now. We understand each block in detail. Like, what is information source? As we know that communication system establishes the communication bridge between the sender and the receiver. Now, to establish the communication bridge between sender and receiver, first we need an information to be transmitted. This information could be audio, video, this could be some picture, or this could be simple text, various forms of message, right? So this is required. Like now, the information is in the form of audio when I am communicating with you, right? Not audio actually, it is video, because you are receiving, you are actually seeing this, you are listening to it. So this is actually video communication. All this communication we do with our mobile, calling, audio communication, video calling, video communication, transmitting pictures through various social media, picture communication, text, we message each other, right? So these are the form of information that could be transmitted. The information generated by the source may be in the form of sound, which is human speech, picture, which could be through any image source. This could be through words, that is plain text in some particular language such as English, French, German, anything, any language. Now next block, after my information source, my next block is input transducer. What is my input transducer? As the name suggests, it is an input, first thing, it is a transducer. What is a transducer? It is a device that converts one form of energy into another. Now, what is an input transducer? The transducer which is used at input terminal, at input end, at source side, that is called as my input transducer. A transducer is a device which converts one form of energy or signal into another form of energy or signal, right? A transducer is present at the input side and output side. Transducer is present on both the side, input and output. So if at input your message is converted from A form to B form, at output transducer, job of the output transducer will be to reconvert back, that is from form B to form A again, that is into original form. The transducer that is present at the input side of the communication system is called input transducer. Generally, the input transducer converts the non-electrical signal into an electrical signal. Usually, in electrical form, we do actual communication, but the information is not in electric form initially. The information is usually in audio, video, text or picture. Now, this has to be converted into electrical signals because my radio waves carry my electrical signal and those are transmitted. So, whether it is radio wave communication or line communication, I should be having some analog signal or electrical signal, right? So, it usually converts my input information into electrical signal. That is sound signal or light signal into electrical signal. The best example of an input transducer is the microphone, which is placed between information source and the transmitter section, microphone, right? what it is doing, it is taking my audio signal, it is converting into, but this microphone is converting it into electrical signal, right? Placed between the information source and the transmitter section. A microphone is a device which converts your voice signal into electrical signal. You know, when you turn on your video calling or you join any meeting over Google Meet or other platform, it asks to turn on your microphone. It asks you, right? So what does that microphone does? It converts your sound energy into electrical signals. So after the information source, input, transducer, next we have is transmitter. This is one of the main block of communication system. I won't say this is the only main block. If I eliminate some extra blocks, then also what I have is information source, transmitter, channel and receiver. At least I need these blocks and the final destination, right? What is the job of a transmitter? As the name suggests, it is used to transmit my signal, right? Actually, transmitter is the main block of a communication system which does all the necessary alterations into my available signal. Transmitter is a block which is lying between information source and channel. Now, this is a block which is connecting your information with the channel. This is actually facilitating your information source to the channel. So, the job of a transmitter is to check the characteristics of input signal and match it with the available channel, and it checks whether the input signal, whether the channel can process the signal, whether my channel is able to propagate this signal as it is. If not, what all necessary alterations are required. If some alterations are required, those alterations will occur at transmitter, right? So, job of a transmitter is to match the characteristics of input signal with the available channel, and it checks whether the channel is capable of carrying the information signal as it is. If not, it does the necessary alterations. What are those necessary alterations? The main alteration that my transmitter does is modulation. First, we go through it. Transmitter is a device which converts signal produced by the source into a form which is suitable for transmission over a channel or medium. Transmitter uses technique called modulation to convert electrical signal into form which is suitable for transmission over a given channel or medium. Modulation is the main function of a transmitter. So, in exams also, if you are mentioning about transmitter and somehow you miss to mention about modulation, this will be an incomplete answer. So, you need to mention about modulation. So, what is modulation? This is, I'll give you a superficial overview. We'll talk about modulation in detail in the coming slides. It actually shifts the frequency of signal so that it propagates through radio wave. Simple example, audio frequency 20 to 20 kilohertz, radio frequency in megahertz and gigahertz range. Your audio has to be transmitted through radio waves, so your signal gets shifted. So, we don't actually alter the actual message signal, but somehow we use some high frequency signal that will carry the information. That process is called modulation. That is a whole lot of, there are a whole lot of things involved which we study in detail in the coming slides. Modulation increases need of modulation strength of the signal without changing the parameters of the original signal. We do not alter the actual message signal. If we change the frequency of actual signal, I lose the essence of the signal. Suppose one wave is 15 kilohertz. How can I change the actual frequency of the signal? If I change the actual frequency, I lose the essence of the signal. I lose the essence. I lose the main content of the message. So, I don't do an actual physical alteration in the message signal. Somehow, I make it propagate through high frequency signal through radio waves, and it reaches the other point which could be geographically too far. Thus, the resulted signal overcomes the various effects which makes it to become weak, right? Next is, after transmitter, we have the channel. What is a channel? Communication channel is a medium through which the signal travels, right? If you would have been sitting in front of me, air is the medium. Now you are using digital media to listen to me, to see me, then your radio waves are doing the task, right? Here the channel is radio frequency range, right? The communication channel is a wired or wireless medium. It could be, channel can broadly be classified as wired or wireless, through which the signal travels from source to destination. There are two categories. Wired channel include coaxial cable, fiber optic cables, twisted pair cable, telephone lines, right? And whereas examples of wireless channel are, if I classify my wireless channel, I can again classify it into ground waves, sky waves, sky waves, or space waves based on the frequencies. These are in kilohertz range, up to 10 kilohertz. Your signal propagate along the curvature of Earth, line of sight. This is line of sight communication, right? After that, we have skywave communication, where the signal propagates in megahertz range, right? Where ionosphere, around the Earth we have stratosphere, troposphere, then ionosphere. These have highly dense ions placed. When we propagate signal like megahertz range, those are reflected back by the ionosphere and received at farther distance. So we increase the range of communication as well as the frequency of communication. And through space wave, we use mirrors in the space, that is my satellite, and through tower, we can achieve worldwide communication. So even wireless communication can be classified on the basis of your frequency. The communication channel reduces the strength. While channel is very long, usually your two users are located at physical distance, then the strength of the signal reduces while they are propagated in the channel. So noise is something which is undesirable, but we have to study noise as it gets incorporated within the channel, right? After this, noise is an unwanted signal that enters the communication system via the communication channel. There are different kind of noise, flicker noise, white Gaussian noise. We can study about this in detail in the coming lectures. What is the receiver? It is a device which receives the signal, and what it will do, at transmitter if modulation was performed, at receiver demodulation will be performed, right? TV set is a good example of receiver. It converts back the signal into original form, followed by your output transducer, which the transducer that is present at the output side of the communication system. Why we are studying it together? Because here we have seen that it converts the signal into original form. Original form means if modulation has occurred at transmitter, demodulation will occur here. That low frequency to high frequency was shifted there, here high to again low, right? This is a reception device. Then electrical signal into original signal will be, conversion will be the job of the output transducer. Like electrical signal you receive through your desktop, your laptop, your mobile phone, but those are converted into audio signal and you are able to hear that, you are able to see that. So this job is of output transducer. The best example of an output transducer is the loudspeaker. Microphone, input transducer, loudspeaker, output transducer. It converts electrical signal into sound signal, which are easily understandable by the humans at the destination. Destination is the final stage in the communication system, right? It is a place where humans consume the information. Destination could be the person itself, right? For example, if you're watching TV, you are considered as a destination. There are certain losses in communication system like attenuation. What is attenuation? Attenuation is the reduction in signal strength at receiver. Next is distortion. It is the change in the form of the wave due to some noise, right? Change in its form. Interference. It refers to the addition of unwanted signal, addition of noise. What is noise? Random and unpredictable electrical signals from internal and external environment to the system. Noise is also a signal, but an unuseful signal. If I am talking to you and some person is talking in behind, he is also generating some signals, but that is not useful for me. So that acts as noise for me. Baseband and passband communication we already discussed in detail. This is the classification of communication system or classification of modulation. On the basis of type of message signal also, we can classify our communication system into analog and digital communication. So if I want to classify my modulation, I have two major categories, analog modulation and digital modulation. Under analog modulation, I have amplitude modulation, frequency modulation and phase modulation. And under digital modulation, we have amplitude shift keying, frequency shift keying and phase shift keying. We will study all these in detail. Like I'll take example of an analog signal xt equals to a sine omega t. This is my analog signal. What are the various parameters that I can alter? An analog signal has amplitude and angle. So this is called as if I alter the amplitude of my signal, actually not the message signal, we use an additional carrier, right? Then amplitude modulation, if we alter the angle, this has 2 pi f. If this complete phase is changed, then phase modulation. If we are playing with the frequency, then frequency modulation. All this can be studied in detail in further lectures. What are the various advantages of my analog communication system? Some of the advantages are transmitters and receivers are really simple. They have low bandwidth requirement. Frequency division multiplexing can be used. If I talk about drawbacks of my analog communication, noise affects the signal quality. This is my analog signal. Any in power, any frequency, like frequency close to it, if they have close power, my signal will appear noisy like this. Noise affects the signal quality. It is not possible to separate noise and signal. Repeaters cannot be used between transmitters and receivers. Coding is really difficult. It is not suitable for transmission of the secret information. Various applications include radio broadcasting, TV broadcasting, telephones, and many more. That's it for today. These are my references. Thank you.